In this video, we are going to talk about importing your data into Jamovi and performing SEM analysis using the syntax. So the first time you open the software, this is the interface you see. That may vary for Windows users. So you click on the sidebar here, click on it, you see new, open, special, import, save as export. Click on open, then you click on browse, then you can locate where your data file is, then you double click on the file to open. So now we have our data imported into the statistical software. So by nature, before you can run structural equation modeling, all your items should be scaled. But looking at the symbol here, it's nominal. So when you start with the modeling, it won't do. So you only need to change them to scale. But one thing I like about Jamovi is that it allows you to change the measurement type of variables at once. So the only thing I need to do is to double click on this to open. Click and drag on the first item of your choice and drag to the last one. So this is the last one. So you can click on this. Measure type, continues. Then you click on this arrow and you have your items now scaled. So you see them. So you can decide to save by clicking on your arrow here, save as. So you can browse and locate where you want to save your data. So I'll save mine here and I have it. So mind you, for the first time you see all these statistical menus, you will not find them. You have to download them. So I don't know for SEM, but if SEM is there, you can go ahead with that. But if it is not there, just click on model, then you go to Jamovi library, then you click here search, just type SEM, you see it, then you install it and close. So the moment you close it, you see it appear here just like mine. So since I have it, I'm just going to click on SEM. You see the interactive, that one allows you to just put in your factors and also your indicators and you are good to go. But since we are using the syntax, just click on syntax. So you look at something. Whilst you open this, you can close it. But since you are going to be looking at the items whilst building your model, you can just click and hold and create some small space that you can be seeing your item names. So in our first skill, we were measuring instrumental help game behavior. So I can just say instrumental, then I put my syntax as we learned in the previous video. It means I want to say that this is my latent variable and the indicators are those I'm now going to add. So I'll just say IHS. So this should correspond with what you have provided in your data. So IHS1 plus IHS2, IHS3, IHS4, IHS5, IHS6, IHS7, IHS8, IHS9, IHS10. So once you are done, just click on the green, you see it's run, just click on it and wait for your data output. So see it's done, scroll down, you see overall test, we see our measurement model. So in our measurement model, we want to look at our factor loadings, and here you see observed, that's the item, estimate, that's the unstandardized beta coefficient or factor loading. SE is the standard error and the 95% confidence interval for the estimate. So what we are more interested is this, B, that's our standardized factor loading. So you see this has a loading of 0.28, this 1.57, 0.64 approximately, 0.50, 0.68 till the end. So since we have so many scales to measure, you ignore this. Just click on this and press enter. It gives you another paragraph. So you can scroll here and look at the next item and latent variable to input in your model. So here we have EHS, so it means that executive instrumental help-seeking behavior. So we just say executive, you can even abbreviate in the same format, syntax. So EHS1 plus EHS2 plus EH3, EHS4, EHS5, EHS6, EHS7, EHS8, EHS9, EHS10. So you click run again, and that variable, latent variable, adds to the present. So you see we now have executive. So you can check the the factor loadings, and you see that the first item, we have a constant, so that's why this is not showing the Z. So we have 0.6, 0.8, 0.69, 0.77 or 0.78 to the end. So if you look at it, it looks like the loadings are pretty great. So we are left with the last scale, which is avoidance. So avoidance, the same thing. So let's look for the item names. So AHS1, AHS2, AHS3, AHS4, AHS5, AHS6, AHS7, AHS8, AHS9, AHS. So I think we have only 9 items. So we just leave this and we run. So let's wait for the output. So we can now close this. So once you are done with all your skills or your dimensions, after checking your loadings, the next thing you should look at is your model fit indices. So let's look at the avoidance before we go into that. So you look at this, you see that the lowest loading was 0.709, sorry, 0.549, and that one also looks pretty great. So you scroll down and you see intercepts, covariances, and variances. So we need to look at the comparative fit, the CFA. So that brings us to another thing. So we have cutoffs for the indices. This helps in the interpretation of our model. So when you have a C-mean or chi-square that divided by degrees of freedom to be less than 3, or it means that it's acceptable, less than 5, that's mediocre. So it means that if you are using this, you can provide citation of this. With CFI, they are saying 0.7, others are saying 0.95. So if you are also using these, you can cite this. Same way till the last. So let's compare that with our model. But you should bear in mind that we need to consider looking at our loadings and also our reliability and validity measures. So when you look at this, you realize that here 0.7 is recommended or greater than or equal to 0.5. However, you can see in other studies where 0.4 as just for interpretation purposes. So these are also considered. In CFA, 0.7 is recommended. In EFA, 0.4. But we are doing CFA, so we should consider 0.5 and above. So since we need to consider our validity and reliability measures, we need to go down here and look for output. So when you go to output, you see additional fit measures. So you see additional fit and model fit. So you check this. So whilst we wait for the output. So according to literature, an AVE, that's average variance extracted, should be at least 0.5 or above. If it is below that, it means that you have convergent validity issues. So whilst you are looking at your loadings, you are also considering your AVE. The moment your AVE is 0.5 and above, you can stop deleting items from your model. So when you look at executive, we do not have any issues. It's 0.5 to 9. It means that it is above. Avoidance is 0.48, which is approximately just closer to 0.5. However, there is a need for improvement. So let's consider working on the avoidance before we move to the instrumental. So let's go up. Avoidance of help-seeking behavior. Let's look for the estimates and the B coefficient. So avoidance, you realize that we have the lowest, which is 0.549. So let's consider deleting item 9. So AHS9. So we just click here and delete it. Then we'll rerun the model. So let's wait for the output. Yes. So let's scroll down and look at our AVE. Our AVE is now 0.51. That means that we have good convergent validity. Let's consider working on the instrumental. So with instrumental, the lowest one was item 9, which is 0.464. So item 9. So let's consider deleting it. So we just click here, then we'll delete item 9 and rerun the model. So you click here. Once we wait for the output. So let's go back to our AVE. It's still very low, 0.282. So we still need to consider deleting. Mind you, we are not looking at the CFA or the model fit indices because sometimes whilst you are able to work on the AVE to be above 0.5, it reflects you are more likely to get 0.9 and above. However, if you are done with the AVE, you have a good convergent validity, but you still have issues with CFI. There are other measures you can take, but we have not reached there. So let's consider ensuring that the AVE is above 0.5. So now let's look at the next one, which is item 6, which is 0.265. So item 6, let's delete item 6 and run the model. Let's go back and check the AVE. It's now 0.316. Let's go back again and look for one with a very lower loading. So let's look at which one has the lowest. Let's consider, if you look at the estimate, you see that IHS1 is 0.29. Let's consider swapping. Let's bring it as a second to see how our model will look like. IHS1 here. So IHS1, let's run to see how the coefficient is. We have 229.229. Let's look to see whether it's high. It's still very low. You see, it means that we should consider deleting the item IHS1. So we'll delete it and we'll run again. So let's go down to look for the AVE. AVE is 0.377. Let's look at our model fit, 0.88, 0.87. So we still need to delete more items. So, and the most recommended minimum item for each latent variable indicator is 3. So you should have a minimum of 3 indicators for a latent variable. So we should put that in our mind. Let's look at the next one, which is 0.500. Let's delete it. IHS4. Let's run. Let's check the AVE. We have 0.402. There's a lot of improvement. Let's go up again. Let's look for the lowest. The lowest is 0.550. So let's check 550, 0.550, which is item IHS. Let's run. Let's go down. 0.42. Let's look for the lowest. And so IHS 2. Let's run. Let's go down. We have AVE of 0.458. So let's consider deleting another item. The lowest is 0.619, which is IHS3. So let's run. Let's go back. Let's check this 0.472. We cannot delete again. So now let's look at our model fit. We have good model fit. However, we need a lot of improvement. Look at EHS1 is 0.492. 0.492. Let's consider leaving the IHS4 and delete items in the other constructs. IHS4. So let's run to see. Once we delete, okay, this is 0.5. Let's delete item EHS1 and rerun. Let's consider screening. Let's consider screening. model fit. We have 894. Let's go to this 58. Let's consider deleting our EH4 again, still problematic. Run the model. Let's go down. We have 0.47. 0.47. Let's consider deleting point item 5 and the instrumental to C 5. Let's scroll down. So do not get a good AVE. So let's bring it back. IHS 6. Let's run the model. No, this is very low. This is very low. Let's put 8 there. Point 4. So let's look at the AVE. 0.43. 5. Very low. Let's consider using 4. This is very low. Let's consider using 9. This is very low. Let's consider using 8 again. This is very low. Let's look at our. This is very low. Let's look at 6 again to see improvements in our model. This is very low. Let's use 5 again. Five is good. Let's go down. Let's see the AVE is 0.47. Since we do not have any other items, deleting another item would violate the recommendation. So just ignore it. So now let's look at the CFI or the model fee. You see CFI is 0.905. CLI is 0.89 approximately. So let's look through the other variables to see whether there is any problematic. So let's consider deleting. Since we look at it, you see that the loadings are above 0.6. Here they are also above 0.6 except AHS8. So let's consider it in AHS8 and run the model to see whether there will be improvement in the model fit measures. So let's go up. See, so they still have the same. Means that let's consider no. Since we have loadings above 0.7, so it means that we can consider looking at the modification indices. Our RMS EA is 0.8, which is exactly the recommendation here. Above 0.8, sorry, this is acceptable. However, we still have issues with our CFI measures, CLI. So they should also be 0.9 and above. So we can do this by simply doing a covariance. So let's go and look for modification indices. Click on it and you go down. You should bear in mind that any covariance you are making, if you are covarying error term, they should be within the same construct or latent variable. You can't do it across any other. So let's look at this. So in order to know all this, we need to visualize our path diagram. So you click here, then you click on path diagram and show beta estimates. If you say coefficient, that's an unstandardized. But when you say coefficient, it means that you want to see the standardized factor loadings. So this is our path diagram. Let's pick for it and the modification indices. It's a bit slow as compared to Amos and others. So let's look at our path diagram. So this is how it looks like. However, let's start by building our second order CFA. So as we mentioned earlier, we can decide to do the error term covariances before. So let's look at this. Which one has the highest modification indices? E6 and this is very high. That's EH6 and EH7. Since you see their names EHS, EHS, we think that they are the same. So we can covary them. So we will now apply a covariance here. So EHS 6, then you covary EHS 7. So you run to check your model fit indices again. So you go back and check your model fit measures to see whether you have good fit indices. So you see we have 0.92, 8892. Let's look at our RMSE. It has reduced drastically. Let's look at our, maybe still the same. Still have the same. So you can start to covary. Some say you can covary once for your error terms. Others are saying the maximum should be 3. So let's do another one to see whether there will be good improvements. So EHS 3 and 4 are all within the same. You can say EHS 3, EHS 4, do the same thing. So run. So let's look at our fit indices before we go and look at to see we have good indices here. Let's compare it to the one we have in the table. C-mean should be below 0.5. So let's look at our C-mean, which is this. divide, that is where 350 divided by 147, that's 2.38, 3249 divided by 171. Okay, so with the user model, 350 divided by 147, we have 2.38, which is below 3, that is acceptable. The RMSE should be less than 0.08, this is 0.07 approximately, that is good. CFI 0.934, acceptable. TLI 0.92, above 0.9, acceptable. NFI, since we are not looking, let's look at the GFI. We don't have GFI here. Okay, GFI is 0.96, I guess the 0.95, that is good. AGFI, okay, we have all above 0.9, that is good. So it means that since we have issue with AV, we can decide to state that in our paper. However, let's look for the composite liability, another measurement. So let's look at the liability. I think that will be up. It's under the AVE we're looking at. Okay. Instrumental is 0.7, executive is 0.9, avoidance is 0.89. So we can say that the final items we derive from this are good. So this is how we perform SEM. Whilst you input your latent variable and your items, you try to work with the fit measures. So you consider looking at the AVE together with the fit indices, whilst also looking at your loadings, and you'll be able to validate or confirm your hypothesized model. So if, let's say, we want to do, let's say I want to import this, so I'll just pick the output here. Copy, just open wide, let me create, let me paste it here. Okay, so this is my output. This is the output, which you can still trace. So let's say you want to do second order CFA. I'm just going to go down again. That's one thing about using the syntax. I'll just come down here and say academic help seeking behavior. Then I put my syntax. So instrumental plus executive plus avoidance. So you click 1. So okay, Lavan multiplication could not compute. Okay, so let's try closing the multiplication indices since we are now doing CFA. Okay, it's now coming. So let's wait for the output. Okay, so what are they saying here? Okay, so since it's second order, see that we still have. Let's confirm that from our reliability measures. Okay, we still have the same. It's just the diagram, so we can copy the diagram and so we paste it down here. Okay. Okay. So this is how we perform confirmation factor analysis. You can do that for one scale using the same procedure where you check the factor loadings together with the AVE and also the fit indices. So this is how we do it, and have a nice day.